Hello everyone and welcome back to another video. So since you have already learned about what a titration reaction is and how you carry out that type of experiment, now we're going to go into a step-by-step example of how to calculate the unknown concentration of an acid or base. In this case, it's going to be the acid that will be the unknown. And you've already seen an example of this in the video, but now we're going to go more step by step. So let's say we have 25 milliliters of a 0.5 molar solution of NaOH. So that's in blue and that is our base, okay? And we titrate that until we neutralize 50 milliliters of acid. So this is our acid, and it's asking for the concentration of the HCl. So this has to be our unknown, and this has to be our known because we know the concentration of this. So essentially you have the NaOH in your burette, and you know its concentration, and you used 25 milliliters of that to neutralize the acid, which in this case is the HCl, and there are 50 milliliters of that in here, and you don't know its concentration. So we're going to go through the steps for how to figure that out, again, only using an equation that you already know. So we're going to break this down into 3 steps. So the first step is to determine the number of moles of the known concentration. Again, since we've done this titration, we know that the moles of that H plus or the H3O plus have to be equal to the moles of the OH minus. So the first thing we're going to do is we need to figure out just how many moles of that NaOH we have to begin with. Okay, so we're going to use our equation over here. So we're looking for moles. So moles is going to be equal to M times L. So molarity times liters. Okay, again, there are those symbols in case you don't remember how to use the triangle. So we know our molarity of our known is 0.5 for that NaOH, and we need to multiply that by liters. Right now we have milliliters, so 25 milliliters. If we're going to get that into liters, again, you can do a picket fence, or I like to move the decimal. So we're going to move the decimal 1, 2, 3 places to the left. So that means that we have 0.025 liters. So now we're going to figure out how many moles of NaOH that we have. So we're going to have 0.0125 moles of NaOH. And when this disassociates, we will still have the same number of those hydroxide ions present. Now we're going to use this in our next step. So we know how many moles of the base we have. Now we need to figure out how many moles of the acid we have. So in order to do that, we do have to write the balanced, so this is the most challenging part, the balanced neutralization reaction to determine the mole-to-mole ratio between the known and the unknown, so between the acid and the base. Most of the time it's going to be 1-to-1, but you still have to make sure you write it out because it could be a 2-to-1 ratio as well. But for this example, we're going to stick with a simple 1-to-1 ratio. So let's start with writing the equation. So we have our acid, which is HCl, plus the base, which is NaOH. Now remember, this is a neutralization reaction, so we know that we have to get water as one of our products. So this is the H and the OH. Remember, they disassociated, they come together. And what is left over is going to be our salt or ionic compound. In this case, Na is +1 and Cl is -1. You can't forget to do your crisscross. So of course, if we do this, we get NaCl. And in this case, this one is already balanced. We have 2 hydrogens on either side. We have 1 oxygen on either side. We have 1 Cl. We have 1 Cl on either side and 1 Na on either side. So we still have to show the picket fence for this. So again, according to our previous answer, we had 0.0125 moles of NaOH. Again, we're only going to be using this side of the equation for our picket fence. So we have 1 mole of NaOH and 1 mole of HCl. So that's still going to give us 0.0125 moles of HCl. So now we know how many moles of the unknown we have. And now the last thing is to figure out, again, our goal, the concentration of the HCl, the concentration of our unknown. So we know how many moles we have, okay? We just figured that out from the last step here. Again, we figured out how many moles of the known that we had. We used the equation to convert that into moles of the unknown. And now we're using the moles of the unknown to find the concentration of the unknown. So we have to divide that by liters. So they have 50 milliliters of HCl. So if we move the decimal, if we have 50 and we're going to move its left 1, 2, 3 spaces, that would be 0.050 liters. So we're going to divide that, and we get 0.25 big M, which is molarity, of HCl as our final answer. So that would be the concentration of your unknown. Again, with most of these, when you go to write the equation, it will be a 1-to-1 ratio. However, just keep in mind that sometimes it might not be, and one of these could have a 2 in front of it. Again, you have to make sure you are looking at the whole equation, though, when you are balancing. But you're only going to be using this side for your picket fence.